A reservoir of gold lies hidden in Earth's core. Scientists say it's leaking. Gold and other precious metals are leaking from Earth's core into the layers above, eventually making their way up to the surface during the formation of volcanic islands like Hawaii, a new study suggests. The theory results from a 3-year analysis of Hawaii's basaltic rocks, which originally formed from plumes of magma, or molten rock, rising from the ocean floor. Clues in the form of heavy metals found in the volcanic rocks could confirm a suspicion long held by geologists that Earth's molten core is not isolated, but likely bleeds into the rocky mantle, the layer between the planet's thin crust and the core. About 40 years ago, people first came up with the theory that maybe the core is losing some material into the mantle, but the signals we got so far were really ambiguous, said Nils Messling, a geochemist at the University of Göttingen in Germany and lead author of the report, published May 21st in the journal Nature. Now, in my opinion, we have the first very strong evidence that some of the core is actually ending up in the mantle. Scientists already knew that most of the gold on the planet, more than 99.95%, according to Messling, lies hidden in the molten core, along with other heavy elements such as platinum. As meteorites bombarded one another in Earth's early history, a reservoir of these precious metals developed when the core formed about 4.5 billion years ago. But this study suggests that at least a tiny amount of that gold has escaped to the surface, raising the fascinating prospect that, if the leaking continues, more and more of this precious metal could travel from the center of Earth to the crust in the future. Our findings not only show that the Earth's core is not as isolated as previously assumed, we can now also prove that huge volumes of superheated mantle material, several hundreds of quadrillion metric tons of rock, originate at the core mantle boundary and rise to the Earth's surface to form ocean islands like Hawaii, said study co-author Matthias Wilbold, a professor at the University of Göttingen, in a statement. Hunting for precious metals from Earth's core to find evidence of this core-mantle interaction, Messling and his co-authors obtained some samples of Hawaiian volcanic rocks from the Smithsonian Institution in Washington, D.C. Some were taken by a submarine from a deep-sea volcano, but otherwise it's basically just very ordinary-looking basaltic rock, very unassuming, that you would find anywhere on Hawaii, he said. We started with half a kilogram, 1.1 pounds of rock. We crushed it into a powder, and then we melted it in the oven with some different chemicals to end up with a sample in liquid form. From that sample, the team extracted all the elements in the platinum group, which includes platinum itself, as well as the lesser-known rhodium, palladium, iridium, osmium, and ruthenium. The scientists then focused on ruthenium, a silver-gray metal about as rare in Earth's crust as gold. The mantle has almost no ruthenium in it, Messling said. It's one of the rarest elements on Earth, but Earth is basically made of meteorites that crash together, and meteorites contain ruthenium, which went into the core when the core formed. So the mantle has next to no ruthenium, and the core has all of the ruthenium. The same with gold and platinum. Earth's core has 2 layers. A hot, solid metal sphere of iron and nickel is roughly 70% the size of the Moon, with a radius of about 759 miles, 1,000 to 121 kilometers. A liquid metal outer core is about 1,400 miles to 1,000 to 153 kilometers thick and extends to about 1,800 miles to 1,897 kilometers below the surface, or right up to the mantle. In contrast, the mantle, which lies between the planet's outer crust and the molten core, is 1,800 miles to 1,897 kilometers of mostly solid rock. To determine whether the extracted ruthenium was originally from the core and not the mantle, the team looked at a specific isotope, or type, of ruthenium that was likely more abundant in Earth's early building materials during the time the core formed billions of years ago. The vast majority of gold and other precious metals like platinum were likely delivered by massive meteorite impacts during the final stages of Earth's formation, a process known as late accretion, said Pedro Waterton, an assistant professor of geochemistry at the University of Copenhagen in Denmark, who was not involved in the study. The presence of the ruthenium isotope in the basalt samples indicates that at least some of the rock was formed from material coming from the molten metallic core. That's because there is consensus, Messling said, that the material that coalesced during the early stages of Earth's formation does not exist in the meteorite record anymore. He added that the isotope signature in rocks from hotspot volcanoes like the ones in Hawaii is entirely different from any other known rock or meteorite. In other words, the ruthenium isotope Messling found was locked away in the core billions of years ago, so detecting the isotope in volcanic rocks today suggests it comes from the core. It's quite a novel and difficult method, Messling said. We managed to measure ruthenium in rocks that have next to no ruthenium in them. In half a kilo, 1.1 pounds of rock, it was less than milligrams, a needle in a planet-sized haystack. That's quite exciting, for a geochemist, at least. It was a long but very exciting process. So what's the connection with gold? It's chemically similar to ruthenium, Messling said. So if the core is leaking ruthenium, it is also leaking gold in similar quantities. This would be a minuscule amount, however. And even if scientists wanted to extract gold directly from the source, the core mantle boundary, that's much farther down than current technology could drill. In fact, it's about 236 times deeper than the deepest bore ever drilled, the Kola Super Deep borehole in Russia, which reaches a depth of 7.62 miles, 12.3 kilometers. Proof that the core isn't isolated is particularly thrilling because the core and the mantle shouldn't interact at all, Messling said. Their density is too different, like oil and water, so technically they shouldn't mix. And we still don't have a good mechanism to explain why they do. We don't really know much about the core at all, he said. The Hawaiian rock samples suggest that the leaking process takes between 500 million and 1 billion years to complete, Messling said. It's something that has occurred a while ago, and we suspect that it probably has been going on forever, and it's probably still occurring now, he explained. According to Messling, if the leaking of precious metals is an ongoing process, it could be that at least some of the gold humans have mined may have come from the core, even if the quantity of core material in a single rock is negligible, and that the world's supply of gold seems to be replenishing. It's a very interesting idea that, although this process is tiny and has zero effect if you look at just one island, if you scale it up to 4.5 billion years, it could be that it changes the composition of the Earth, he said. Core mantle interaction researchers who were not involved in the study expressed positive views on the findings. We know that the Earth was built from different generations of meteoritic material that were added progressively to the growing planet, and that precious metals from the earliest generations of meteorite material became concentrated into our planet's core, while metals from meteorites added in the final stages of the Earth's growth became stranded in our planet's mantle, said Helen Williams, a professor of geochemistry and planetary science at the University of Cambridge in the United Kingdom. The study, she added, confirms that the mantle plumes, rising jets of molten rock coming from the core mantle boundary that create hot spots like Hawaii, do indeed contain material somehow derived from Earth's metallic core, said Williams, adding that the result was exciting. Jesse Reimink, an associate professor of geosciences at Pennsylvania State University, agrees. This is a very old debate, and new data over the past 10 or so years has reinvigorated the possibility that the core was chemically leaking into the mantle over time, he said. This study really does seem to nail the conclusion. The core does contribute some material to the mantle. The latest research also strengthens the case made in previous work that some mantle plumes incorporate material from Earth's core, said the University of Copenhagen's Waterton. Does that also mean some of the gold in Earth's crust is originally from the core? Yes, but probably only a very small amount, he said.